Dear students, so as far as we have completed the two videos, one from the first unit that is non-ideal IV effects, and from the second unit that is static logic gates. Now we are having the video from the third unit that is sequential logic circuits from the VLSI design. So before getting entering into the video, let me introduce myself again. It's me, M. Uday Kumar, who is an assistant professor from the Department of ECE, KSR College of Engineering. Right, welcome you all for the third unit, the video from the third unit that is about the topic pipelining. The pipelining, from the name itself, we can able to understand that this topic would be a very important topic because the same word you might have heard it in some other subject also. That is from the microprocessor, you may have heard it from the DSP, digital signal processing, you would have heard it. And similarly, when coming back to the VLS, it is the same topic is again repeated. Since the topic is being repeated in different subjects, you should know the importance of the topic. That is how much it is important. Right. What is this pipelining? So in the real-time example, everyone is having the structure of pipelining might be in their home or anywhere. If you see that this pipelining are a parallel structure that would be moving in the same direction from one end to another end. So this is the key word behind the topic pipelining. Let us have a deep explanation that is pipelining, an approach to optimize a sequential circuits. So pipelining is a popular design technique often used to accelerate the operation of data paths in the digital processors. The goal of the presented circuit is to compute a log A minus B. Some kind of calculations have to be considered where this pipelining is able to solve and produce the solution. So in this situation, I am taking the formula that is log A minus B. I am going to implement the same by using this pipelining structure where both A and B represent the stream of numbers, that is the variables. That is, computation must be performed on the last set of input variables. So if you want to perform any operation, mathematical operation, this pipelining is one of the technique that would be very easier and you can able to complete the solve the problem with a less amount of time. If you're preferring with another operation, this pipelining is very simple and as well as more accurate and often used in the digital logic circuits. In a real-time example, you can say the designing of processor or designing of integrated chip, anywhere these pipelining operations have been implemented. The minimum clock period T minimum, that would be represented as a T minimum, necessary to ensure correct evaluation is given as T minimum is equal to TCQ, TPD logic plus TSU. What is meant by CQ and SU? They all are the propagation delay and the setup time of the register respectively. CQ is the time taken for the clock and PD is the propagation delay. Then SU is about the setup time. The term PD logic stands for worst case delay path through the combination network, which consists of added absolute value or logarithm function. So if you take an example for doing a calculation or manipulation, you can take adder, separator, shift register, counters. So whatever the even flip flops, whatever the logic circuits you can take. But the most important thing is we are obtaining the solution with respect to the propagation delay. So if there is a propagation delay is more than our time taken for the operation to perform is also more. So in order to overcome all those things, I am just moving into the power concept called pipelining, in which the delay can be calculated, which is very, very, very less when compared with the other technique, or the moment that we are doing the calculation indirectly. Just to look at the diagram, the pipelining, an approach to optimize sequential circuit. In this case, I am uh, performing the operation in a two category, that is non-pipelined version and as well as a pipelined version. In a real-time example, you can take a 100-meter relay, that is 400-meter relay, 4 into 100-meter relay. So here what is mean that the A and B are the variables. It would be any number. You can say example 2 or 3 or 4, 5 like that, anything. That will be stored in the register, and after it is moving into the box. The non-pipelined version is consist of does not have any registers when compared with the pipelined version. The pipelined version is having the registers, in which means that the variables are one over is always stored in the register before entering into the operation. Once the operation is completed, the second thing is going to happen. For example, I want to do something, that is the A plus B. I take out the value of A and put it over the register. Next, I'll take the value of B. I'll put it over the register. Now, what I'm doing is I just perform the operation, that is A plus B, and the next thing is I put the value of output in the register, and then finally to the destination. But whereas the non-pipeline version is considered, we don't have the registers along with the clock. So this is a simple thing, but having registers are more appropriate. The advantage of pipeline operation becomes apparent when examining the minimum clock period of modified circuit. Here, the combination logic block has been partitioned into three sections: smaller propagation delay than original function. T minimum pipelining is equal to TCQ maximum TBD at TBD absolute TBD logarithmic. These are the three values have been calculated, and finally they are united together and find out the solution for the process of calculation by using the pipelining technique with the help of the memory devices. Suppose that all the blocks have approximately the same propagation delay and the register's overhead is small with the help with the respected to the logic delays. The pipeline network outperforms the original circuits by factor of 3 under these assumptions. The increasing in the performance comes at the relatively small cost of two additional registers and increased latency. So these pipelining probably may be asked in the 7 mark or 8 mark question, and very rare case it will be asked in the 13 mark question. If we are asked like this, just put out the two diagrams, non-pipeline structure and pipeline version. Just explain the manipulation by using a table column. The same thing has been given in the textbook, that is VLSI. So just refer among that, and if you are having still any more doubt in that, so please feel free to uh, comment. I'll be explaining the same again with the new version. So thank you for watching the video. Hope you have understand everything regarding the pipelining, and this is the important topic as far as the design is considered. Okay, thank you, and we'll be having the next one from the fourth unit, and with a better topic that would be familiar to you. Thank you.